3, 2, 1, go.
Hello, everybody. Michael here from sunny Charlottesville, Virginia. Wait, no, it's been rainy today, and it's not even light out. But we'll roll with it.
Get with the lesson.
What?
Get with the lesson.
Yeah, Sam, I'll get with the lesson. God. Okay, so as the magic board says, we are going to be talking about heat transfer today. And its three forms, which are conduction, convection, and radiation. Now, conduction is probably the one most of y'all found out when you were a little kid and you had, oh God, that's a terrible drawing. Let's say a stove. And your mom told you, don't touch the stove, and you touch the hot stove. And congratulations, good, screw it, that's a hand. Any case, you found out what conduction was the hard way. And the conduction happens because we have vibrating molecules, or atoms. Let's say these are just atoms. And then you have one that's vibrating more so because it's hotter. So it transfers energy to the next molecule it hits. Basically, that's the atomic definition of heat transfer. So, pretty much what's happening is the atoms of your hand are touching the atoms of the stove, and heat's transferring between them, and your hand doesn't like that too much. Mathematically, we define it with Fourier's law, which is written on the board. Slightly sloppily, but still there. So I wrote all my equations with the flux, which is basically just the heat transferred over the area, cross-sectional area it was transferred. So it's just the negative of the temperature gradient because heat travels from coldest to hottest to coldest. And this constant right here is called the thermal conductivity, which basically just is a material property which explains why glass doesn't conduct very well and aluminum does. See, it's in the name, conductivity. So now we're going to go to the second one, because that's about all we can do with conduction, except for if you don't like gradients, which I won't blame you if you don't. We can just simplify it to, if you're looking at a one-dimensional case like this, where we just replace the gradient with the derivative with respect to x. So convection is more of like how you boil eggs. So you got a pot here, and my pictures are all sloppy, but I hope they serve their purpose. So we got our eggs in the pot. Now clearly the distance between the bottom of the pan and the bottom of the egg is too great for any vibrations to be transferring the heat. So what happens is, if we remove the eggs, I'll put it up so it's still on the screen, is that we got water here, and here it's hot. So it makes it rise. But up here it's cold. So this starts to sink because the density is higher here than it is here. And so pretty much now you have this bulk current which is transferring the heat. And it's described by this equation. I don't really remember who made it or what it's called, but pretty much it's very similar to Fourier's law, except it has this H, which is not the thermal conductivity. And basically, the big difference between this and this is that this is a material property, while this depends on, say, if you're blowing. Well, if it's like a fan in a room, it would conduct the heat differently as if it was just naturally moving. So this takes into other factors other than the material that's conducting the heat, and then you have your temperature difference. Now, radiation, of course, I'm not going to be able to draw a picture of this one, but it's basically why you get sunburn.